physical quantities. So all the measurable quantities are called physical quantities. And the key characteristic of the physical quantity is that they must be having a magnitude and they must be having a unit. These characteristics, these are more important even than the definition of the physical quantity. You can define physical quantity as quantities which can be measured, but this is the most important part that you need to be aware of, that the physical quantity must be having a magnitude and a unit. Now what is a magnitude? Magnitude is the numeric value, or in simple words, it would be a number. Now this number could be positive, it could be negative, because the physical quantity that we are referring to could be scalar, it could also be a vector. And the unit, it is the standard in which we measure the physical quantity. So we always first we set a standard and then we compare the physical quantity with that standard, and that standard is called as a unit. Can you name any unit for me of any physical quantity?
For to find out the length we use centimeter meter.
Okay, excellent. Yeah, that's totally right. Absolutely right. To measure length, we can use centimeters, we can use inches, we can use kilometers, we can use meters, millimeters. There are plenty of units for length. Now, as we have defined physical quantity, now we need to be aware of that there are 7 base quantities. There are exactly 7 base quantities. 7 base quantities are there, and 5 of them would be used as it is in our syllabus, and there are 2 of them which would not be used directly, or you don't have to memorize it, but if you want to do it yourself you can. Now what are the base quantities? So as you pointed out that we can measure length in centimeters, the physical quantity length itself is a base quantity. In order to define length, you do not have to take help of any other physical quantity. If you're measuring the time interval, then you don't need assistance of any other physical quantity. But let's talk about speed. Now speed depends on 2 things: how much distance is covered in a specific amount of time. So I consider 2 things: distance and time. So let me define base quantity first, quantities. So these are the quantities which do not depend on any other quantity for their definition. They have their own existence. The analogy is, you can think of the primary colors, the base color, the primary colors, RGB. You might have heard this word in electronics. All the colors are produced from these 3 colors: RGB, red, green, blue. So for colors, you can say that these are the base colors. Likewise, the quantities which have their own existence in all other quantities are derived from these ones are called base quantities. How many of those quantities are there? Only 7. 5 of them are to be memorized by you, and the rest of the quantities is your choice if you want to memorize those. So let me enlist 7 base quantities. You can enlist them in the table. So what do we have? The first one. So let's go with the same one that you came up with. Now the unit, we have to be very careful here. The unit that I'm going to write here would be the standard unit. So you see there are plenty of units. For length, I mentioned a lot of units: meters, millimeters, centimeters, inches, light years, kilometers, yards, feet. There are a lot of units for length. So we have to make a specific unit a standard one. That unit is called as SI unit. So the unit that I'll be writing here against the quantity would be the SI unit. And guess what? The SI unit of length is meters. Any other quantity that you can think of?
Mass.
Okay, very good. Mass. That's excellent. Mass. And there are a lot of units for mass. For example, grams, kilograms, milligrams, pounds. But the standard unit for mass is kilograms, which would be represented by kg. Time. Time is also a physical quantity, and more importantly, time is also a base quantity. Time has its own definition. So it is measured in seconds. Once again, there are a lot of units for to measure time. Could be years, could be decades, could be centuries, could be minutes, could be hours, could be days, but the standard one is second, which is represented by the symbol small s. So the next one that we have is thermodynamic temperature. Can you come up with the unit of temperature?
Degree
Like for the
Celsius.
okay, very good. Degree Celsius, degree Fahrenheit, but the standard one is Kelvin. Kelvin with the capital K. Okay, this one is capital because all the units that are named after scientists would have the capital symbol. For example, Kelvin. All right. Up next, we have another one which is electric current. So the word current itself means kind of a flow, the disturbance, the flow of something due to disturbance in a medium. So we have to be specific here. We say it electric current, and electric current is measured in the units of ampere, which is once again named after uh, Ampere, a physicist, and that goes with the capital letter. The symbol is capital A. So these five you need to memorize. You have to memorize these five at least. The other two is your choice. If you want to memorize, you can, but I'll just write anyway. One of them you might have used in chemistry, which is measured in moles, and the symbol for that is MOL, mole. So the yellow ones, you don't need to memorize these. And the last one, the seventh one, is intensity of light, also known as luminous intensity, which is measured in the unit candela, which is represented by the symbol CD, small c, small d. So these are the seven physical quantities, I should say, seven base quantities that you need to memorize. And the SI unit is very important one. Throughout the chapters, we'll be referring to these ones. We'll keep referring to these ones. And the most important part is that you have to be careful with their standard unit. So if, for example, if in a certain question you're given with the length, but the length is given in centimeters, then you have to convert the length into meters. Unless they ask you to give the answer in centimeters, you have to convert all the quantities into their SI base unit, unless mentioned otherwise. If it's not mentioned, nothing is mentioned, you have to convert it. That's obvious. A very easy thing. The only point is throughout the chapters, whenever you have to write the answer of a physical quantity, then you got to be careful with two things. The answer must be having, if it is a physical quantity, the answer must be having a number and a unit. For example, you're asked to calculate force, and the value for force that you calculated was 10. So how do you write it? You write the number and then you write the unit. So these two things have to be there.